Hello, today we are going for one kind of force that is different than other things like normal force and friction force. So, the force is pseudo force. What is pseudo force? So, pseudo force is our topic today to learn. It is very easy and it is very tough in the numerical. It is very easy to understand, but for the numerical, it is little bit tough. Okay, how it is tough and how it is easy, it will be decided later. The example for the shooting post like when you are in the lift and you push the button one or two or three, you suddenly feel a jerk. When lift is going upside, you feel downside jerk. And if you are at the third floor or fifth floor or second floor, any floor, and you go to the ground floor and you push the ground floor button, you feel the jerk on the upside. Have you felt that ever? It may be you have felt or not felt, but most ofly you have filled this kind of application. This is the bike. Okay. So I had made a good Yamaha bike, R15 or something R series. Okay, so suppose you are here and suppose one person is driving this and you are here. Your friend is here and you are with your friend. Okay, suppose when it is in hurry, it start accelerating. You feel the backward jerk. हो ऐसे ऐसे होता है कि नहीं होता है? बिल्कुल होता है. So तुमको किसी ने छुआ भी नहीं है. Okay, you are not connected with any other forces other than the bike. So bike start accelerating suddenly and you feel the force backward direction, that is the opposite of the acceleration of the bike. So that force is known as pseudo force. Okay, bike doesn't give you a force, but it is accelerating with some a, and that force, suppose your mass is m, and from m into a will be in the opposite direction of the of the bike. It will be like that. So that force in bus also sometimes we feel like jerk in the backward direction. Okay, it is also possible when it suddenly brake. Okay, it is accelerating. Suppose it is braking, and what you feel? Oh, ऐसे आगे गिर जाते हो तुम आगे की ओर. You move towards forward direction because acceleration is in the backward direction. When braking is there, acceleration happens in the backward direction, backward of vehicle. Backward direction. Then force on you will be in the forward direction. Pseudo force is in the forward direction. It is always opposite to the direction of the acceleration of any other body, either it is a lift Either it is bus, either it is some kind of inclined plane, or some kind of anything. Okay, sometimes it is a rail. Okay, rail compartment. So there are lots of things. Okay, when the acceleration happens, the body and the system start the pseudo force on the opposite of the acceleration, and mass of that person is multiplied, and then you can calculate the total force. So pseudo acceleration into mass is the pseudo force. Okay, pseudo force can be calculated. F pseudo is equal to mass into pseudo acceleration. Okay, and the other thing is for the pseudo force is opposite, always in opposite direction to the acceleration. So what about the magnitude? Magnitude remains same. Magnitude remain same. So this is A, the A will be here. This is A dash, that will be A dash. Okay. So whatever the acceleration is there, you will feel the retardation in the backward, means in this opposite direction. Acceleration, retardation. Okay. So let's start some numerical with that. For example, suppose there is a one lift. Here is a man standing on the waiting machine. Okay. The first case, suppose man has a mass of man is 55 kg. So the waiting machine shows 55 kg at steady state. Steady state waiting machine shows m equal to 55. Second option, suppose lift is accelerating upside with 2 meter per second square. Okay, lift is same like the bike. So you will get 2 meter per second square downward direction. Okay, so what will be the next mass? Accelerating upside with 2 meter per second. So what will be the mass showing by the waiting machine? See, waiting machine shows mg actually, but we neglect the g. Okay, so net force on the man will be what? Mg plus a. Now mg is equal to 55. 55 10 plus 2. So 12 into 55. Okay, so what will be that? Here we have neglected the mass of this. It will be how much it is? 55 into 10. 550 plus 110. So 660. So this is total net force. And if the G is equal to 10, Then, yeah, we already have. It will show the 66 kg divided by g. Got it or not got it? Is it easy? Sir, how you calculate this? See, it has already in the steady state FBD. Let's make an FBD. It's mg and normal force. Both are equal. Okay, so m equal to mg equal to 550, and the weighting machine shows m equal to 550 divided by 10, so 55. Now for this, let's make an FBD. Acceleration is upside for the lift. Here it will be mg and another me, because it is accelerating. It is creating pseudo acceleration in this body downwards. So total net force is not moving in the lift upward or downward. So n equal to mg plus ma, like making this. Okay, we will get this 66 kg. Suppose it is going downward with 3 meter per second per case, or 5 meter per second, 5 meter per second square. So acceleration will be in topward direction. Let's make an FPD. N is there, mg is there, or minus m into a. So n minus 55 into 5 equal to 55 into 10. So net n is equal to 55. Okay, here it is. It is in opposite direction, pseudo force. So 55, 10 minus 5 is 5 into 55. And the net force, net mass shown by the weighting machine will be 55 into 5 divided by 10, 5 to the, and 55 divided by 2, that will be 27.5. Is it clear? It's a very good questions and very good understanding of pseudo force by this lift example. There are another examples on the pseudo forces. Let's go for it. But hope you this is understanding. Acceleration is there, the pseudo force will be there. There are more than one or two bodies. There is man, there is lift, there is a bike, there is a man. Okay, let's go for it. Next example. Okay, let's make a simple example. So theta, this is m and this is it starts accelerating. Okay, it starts accelerating, and we have to find what will be the acceleration of small m. This is the surface. Okay, see, on capital M there are two forces, one kind of this, and you start acceleration due to some force. Due to some force, you start accelerating in this direction. Now n equal to mg. Okay, let's make an FPD for the capital M. it's mg downward, and there is normal force by the surface upward. Just wait a minute. So here we have two forces mg and n. Now another force by block m on this surface will be like this. Means mg, this will be mg cos theta, and this will be mg sin theta. I have divided mg to the two components. Okay, so we are finding the acceleration of m. Okay, pseudo acceleration of the m will be in this direction. Yes. Okay, if this is accelerating, this will start also accelerating. A has some component in this direction. In this direction, it has also some component. So let's make it. I will do this later. Uh, this is theta. Here it is also theta. Let's make this 90 minus theta, and here it's a 90. This total 90. This will be theta. So A has component A sin theta. You got it? In the upward direction. Okay, and not force on the upward direction will be m into A sin theta. So m has total two forces, mg sin theta in this direction and ma sin theta in this direction. So net acceleration of ma dash is equal to g sin theta minus a sin theta. It may be positive, it may be negative, depends on the a and theta. Depends on a and theta. If a is positive, then it is going down that. If a is negative, it is going upside. Is it clear? It's very easy. Here we do not have any considering friction force. This is only pseudo force. Pseudo force is going in this leftward direction. And the two components, one is this and other is this. This will not help to move the mass, but this will help. So ma sin theta and mg sin theta both are on the same axis. You got this? So a dash equal to g sin theta minus a sin theta. Hope you get this equations. How can be calculated? Okay. So sometimes it is called it is classification asked how much time m has uh, required to reach the top or to require to reach the bottom. Okay, whether it is going in which directions depends on that questions can be asked. Okay, so these are the pseudo acceleration and some few basic examples on that topic. Thank you. Again, we will later some numericals related to this, like pulleys and their